So I make this smaller for now, and for this I'm gonna decide on a perspective that we're going to render here, and I'm happy with that, so I'll just use that. And for this I want to do something. I want to give Arnold some time to actually clear the rendering up a little bit, so let it give some time to actually sample this glass canopy a little bit more, and then I want to store a snapshot of that rendering. So a snapshot basically is a screenshot of your current rendering. So it's going to turn up down here, and you can use that to compare a few different versions of your rendering, which we're going to do as a next step. So this is basically saved down here as long as Maya doesn't crash. So we will be able to compare some renderings right now to take a look at the variations that we can bring into the surface with this little shader control up here. So let me just create a new camera right here, because I am going to mess up our render camera otherwise, because I like to play around with the mouse in the viewport all the time. So this little thing up here, and I'm going to turn the channel box on for a moment here. This little thing up here is the shader control. So on the main controls of the plane, if I don't want to see them, I can hide them. I can show them. So usually I would not show them, because it's basically a setting that you change on a per shot basis at the maximum. So basically you'll just go in there at a late stage before rendering basically, and just well, change a few parameters actually. So what can we do here before taking a look at the actual setup? So let me just make this smaller again and move it down here. Maybe move this up here. So we've got this shader control selected. So what I'm actually gonna do is, no, let's keep it that way. So I've got this thing selected, and I'm gonna make this a little bit smaller so we can see what we're doing. So you can see on this shader control, there are a few parameters. They're called panel rough min, panel rough max, dirt push, panel seed, and oil method. So let us first take a look at the panel rough min, panel rough max. So over time, this plane would not be as shiny as it is right now. So basically it currently has a roughness on the surface of almost 0. So it's varied by a noise shader, but basically that plane has a roughness of almost 0, so it's pretty much a clear reflection. So over time, those surfaces would kind of like wear down, and they would become rougher, so that plane wouldn't reflect like a clear mirror. So basically I can use these settings to do that. So if I push them up to 1, and that's an extreme value, both of them, my plane will be completely rough. So there's actually no real material that has a specular roughness of 1, but I could do that. As long as I change both settings here equally, I will have made all my panels, all my hull panels will I have set to the same roughness. So the whole plane now has a roughness of 0.5. This is actually, so if I take 0.3, and if you take a look at old World War II footage, this is kind of close to what most of these planes actually appeared to look like back then, but they had a little more step even of variation on their surface, because usually those panels would not wear down all at the same time, and maybe some of them would get replaced. So basically each and every panel had a kind of different roughness on a plane. So while this is actually quite realistic right now in a way that the plane might have looked back then, a lot of them were shiny, of course, at least for a few months, but there's not that much variation here anymore, so it kind of starts to look not as realistic as it did before. So I can actually give this a range of values. So this is between 0 and 0.3, and if I push that again to the extreme here, you may notice that some panels on that plane here are still, like here the wingtips, are still reflecting clearly, while other parts of the plane are reflecting rough. So basically, this is changing per hull panel, and that is the whole reason why I kept those hull panels separated at the modeling stage. This is varying the roughness per panel, per surface on that thing. So if I don't push that to the extreme, but use maybe something like 0.5, this is gonna get pretty clear right in a few seconds. So let me store that right now, so we can compare that rendering to the rendering before. You can see how all of these surfaces basically are completely shiny. So if I go back to this one, you can see how some of the surface will have roughened up, and maybe 0.5 is actually still a bit too much. So let's vary that between 0.05 to give all of them some roughness, and 0.25, for example. So Arnold is going to render here for a little bit, and I'm going to store that. So now, if I take a look at this and compare those two versions, that's still a lot. So let's render that again. Let's make this 0.15 maybe. Or maybe make this 0.08 and 0.2. That should be kind of close to what looks good on that thing. So I'm just going to give it some time to render here again. Store another snapshot. So basically that's that. You can see how some things change here. You can definitely see how this appears to be less rough than this. So let's compare that with the first version. There's some variation over the plane. So what if I don't like the way that these panels are distributed in a way? I've got something called a panel seed. So if I just add another number here, for example 125, and give Arnold some time to render. So it's actually taking the wrong camera, unfortunately. So let me just quickly change that here again. Sometimes it does that. It's a bit quirky. It's basically because I've had this camera open in the viewport, so it thinks it should render that one. It's not Arnold's fault, really. So most likely that would have been the thing that I wanted to do. So let's take a look at that. Let's give Arnold some time to actually clear things up here again. And Arnold is gonna do its thing, and the panel roughness seed now is 125. So let's take a look at that compared to the rendering before. And that is a subtle difference right now, but you will later see how that actually varies. So I should turn off 3D manipulation for now, because I don't want to change my camera. And I'm going to store a snapshot now. And even though my camera has unfortunately changed a little bit, I can see that this wingtip here. So basically, the distribution of the roughness on these panels has been varied and changed. So if I push that to the more extreme again, and I have to be careful here, and I haven't selected any snapshot, or I think that some of the older renderings is my actual rendering. So if I now take this and maybe put this to 3 instead of this, you will see how the distribution of the panels again will have changed. So let me just quickly push that back to 125, which is what we had before. I'm gonna give it a bit of time to clear things up. Store a snapshot, and then go to 3. Let it clear up, and store a snapshot. So now you can see, especially here on the tail and on the wingtips, basically, that this panel is pretty shiny, and this is also pretty shiny in this rendering. In this rendering, those surfaces are rough, this is pretty shiny, and this is shiny. So basically, that's a way I can change the look of the plane on a per shot basis, and I can also vary the look of the plane for different versions of that plane. So as I said before, there are 2 other versions, basically 2 other names of that plane, and I could vary, if I import those assets at different planes, I could vary that attribute on those rigs, and I would have a different look to each of these planes and how the roughness on the panels is distributed. So that's a handy tool on the rig to kind of like change the look of the plane on the fly. And again, if I push that to the extreme and turn that off, you can actually see the difference here between the panels, especially here how that panel now is pretty clear, and this is rough, and then put it back to 0, you will see basically everything here is now pretty much rough, and here's a clear panel. So that's just a way to keep things a little bit more interesting. So let's put that to realistic values. Let's take 0.3 and 0.05, and let's take a look at the other things. So basically, if I can change this panel layout right here, I can also change the dirt on the plane node. So there's something called dirt push, and I kept its default at 0.192. If I put that to 1, you can see that all of these procedurally generated panel lines have basically gotten darker. So basically I've pushed the dirt to the absolute maximum and extreme that I can. And for some shots, and let me just quickly change, let me turn 3D manipulation back on so we can actually work in the viewport right in the render view right here. You can see how that actually pushed all the dirt to the extreme. So if I render this side, just because there's a little more dirt, so there's this little oil stain usually on a P51 where a little hole here would usually leave some streaks over the surface of the plane. So you find that in original footage from World War II on P51s. So obviously that is a little bit extreme regarding the dirt, but I can store a snapshot just to show the difference. So I'm going to push that back to a more realistic value of maybe something like 0.25, which is above the default, but it works. So if Arnold renders now, you will see that the panels, the dirt is much more realistic. But if I have a shot from far away where maybe this detail is not coming through, but I want to keep that detail, I could push that dirt value just to give those lines a little bit more definition, to make it just appear a little bit more rough and used and worn down. So that's how you could approach that, and I find it pretty handy, as I said, to have it on the rig in this case. So you can use that as a tool to change things up a little bit. And the last thing that I want to take a look at right now, maybe put that down to 1.5 right here, because I like that plane a little bit more shiny, and maybe turn around here. So actually this panel roughness variation will be very apparent if some highlight is hitting the plane. So right now you can see that plane is extremely shiny. If I push that up to 0.6 and maybe 0.1, you will see how all of these highlights will have softened out. So it's still shiny, it's still a metal surface, but it is reflecting the light in a very different way than it was before. So I like basically 0 and 0.3. So that's a good middle ground for things, and obviously you can vary that panel variation. But there is this other thing. So this is called the oil method. And the oil method is basically there to keep things compatible with the GPU. So if I just render a selection here, and let me save that real quick, because sometimes Arnold likes to crash if I'm changing render engines. So basically this oil method right now, so this is for this kind of like oil streak here. This oil method right now is called ramp noise. So that's an enum attribute in Maya. So that's an enumerator. I can basically put in names, and they will correspond to numbers in the node editor. So that's 0, 1, 2, 3. So it's currently set to ramp noise. That's one of the methods I can use to shade that oil. There's also this node constant white, which will basically just make it appear brighter than the surface, which is how some of these oil stains like to appear on some reference photos. So I decided to just put it there as a way to change things up in that department. And there's also constant black, in which case this will basically just look like a dirty darkened surface. And there's this thing which I can't render, on the GPU, which actually looks quite nice and is actually the most realistic of those methods, but I can't do that on a GPU, and that is the thin film method, where I'm really using a thin film shader to actually produce this kind of like oily, shimmery, colorful surface. So if I turn back to the CPU here for a moment, you will be able to see that. So this is going to take a little bit more time, but I think you can already see what has been changed. So if I move a little bit closer here, and as I said, this unfortunately takes a lot longer. So let's wait a little bit. You can see that there is this subtle color variation right here. So if I change that back to constant black, which is how the GPU basically would render the thing if it's set to thin film. So, or it's a mix between constant white and black. So basically the shader can't be evaluated, and the Arnold is just deciding on a color to use there. So basically without that thin film, it looks like this. With this thin film, it looks like this. And compared to this ramp noise method, which is basically static noise, this thin film method will actually change with your viewing angle towards the surface. So if I had to push in really, really close to that part of the plane for whatever reason, well, if I had to push really close, I would have probably added some more detail on some surfaces there at the modeling stage. But let's say I would. I'd probably render on the CPU and use this thin film method for the kind of like best look. If I switch back to GPU right now and hope that it does that, but it's become pretty stable here, well, you can see that that look is gone. So I can't do that. So the other thing that you might notice right here is while the plane has become rougher, this dirt material still appears to be very shiny, and it works actually quite good as long as I'm using that oil, because, well, oil as a slippery, slick material, of course, is very reflective. So if I want to have that oil stain right here, that rough, the non-rough, clear material is probably a good choice to do that. But if I don't want to use that, I need a way to change that. So we're gonna change that now and add a little two attributes here to control a little more things on the shaders. But let us first take a look at how this is actually connected or these attributes are actually connected to our shading network from the rig. So basically how this little control up here is connected to the shader network. So let me open the node editor for a moment. So in this node editor here, we want to take a look at a tab, and that tab is called Shader Control tab. So and in this file, I actually haven't renamed those things because I loaded a file that I used earlier. So let me just use that right here. So that's sim attached, because that's probably going to be the file that I'm going to share with you. So this is going to be sim attached to rig tab. Thank you, Maya. And we want to take a look, not at that, but at the shader control tab. So this is the thing. This is the shader controller up here. It's connected to the P51D master because there's this little connection that is a Boolean that just is the show shader control, and it's just connected to the visibility of that thing so that I can turn that off from the thing here. But this is not what we want to look at. We want to look at what's here. So you can see there are our attributes: panel rough, mix, max, min, panel seed, oil method, dirt push. So they are going out to these float constant nodes. They're called rough, max from rig, rough min from rig, panel seed from rig, oil method from rig, dirt push from rig. So as you may remember, we've already seen these nodes. So if I go back to Arnold here, And we're not going to look at Arnold, we are going to look at our node network actually, and we're going to stop the IPR from running for a moment here. You can take a look at this. This is panel seed from Rick, rough min from Rick, rough max from Rick. These are the very same nodes. So basically this is connected to this. I don't want to see everything in one layout, so basically I'm reusing them here, but they are the same thing. You can see actually if I select them, I'm selecting the same thing. So if there's this green outline here, there's this green outline here. So I can actually also drag and drop things from this node editor, from the Hypershade, but this is really just a node editor, to this node editor, that is the node editor. So yeah, that's basically how that's fed to the shading network, because there's no difference between these nodes. Everything is a node in Maya, so I can just connect them straight up. So that's really simple. It's as simple as that. So that's just a simple connection. So that's actually all the magic there is to that. We can take a look at what these things will actually do on our surface. So if I run the IPR again here, and I make that a little bit larger, and I don't need to see my snapshots anymore. And I'm gonna make that full screen now, and I'm gonna try to find the right, this one. So let us drag that up. So that's our plane. I'm gonna zoom out a little bit. Come on. Become a bit sluggish right now, but it probably will work faster in a few seconds again. So let us zoom out a little bit. So the interesting thing here, because the other connections are pretty much well, standard connections, is this color jitter thing. So let me take a look at that, and actually just let me make that a little bit smaller right now. So actually I kind of feel like the team viewer connection is lagging a little bit. Let's hope that it clears up in a moment again. So a AI color jitter node is used to basically produce the magic. What is an AI color jitter node? So basically this node is able to vary properties over things in your scene. So you can tell it to, for every object that this is assigned to, vary your input value. So there's this gain mix, min max, hue min max. So basically per surface you can change an attribute. So there's this concept on random generators, and this is basically for every hull panel here. This is just creating a random number between 0 and 1. So each and every hull panel gets a different number. So the way random numbers are created on a computer of course, is that they have a base, so that when you use that number, you will always get the same distribution of random numbers. So this is called a seed. So this panel seed is connected to this seed value here. So if I go to the rig and I go to the channel box right now and I change that panel seed, you will see that the distribution of random numbers is changed, and therefore the panel is changing. So now this color jitter node is going into a range node, which basically tells the thing you've got this rough min and roughness maximum value. Put that 0 to 1 range between these values. So basically this panel range will be between the rough min and rough max value I've set on the rig controller. So the specular roughness, because this is going into this thing right here. So this is basically added to the noise that I'm generating for the plane. So this noise is already generated to give the roughness, the specular roughness, some variation. And this gives it even more variation. So in the end, and we can see that pretty clearly here, this panel will be way rougher than these panels. And if I again let me lock that selection here for a moment. If I again go to the shader control, change the panel seed, everything on here will have changed. So if I put that to 2, you can see that other panels are now rough and have been changed. So as I said before, I like to do that for our dirt shader, but one last thing I want to show before is another thing. And let me just quickly put that to 0 and 0. So every panel on that plane is rough, is absolutely clean right now. So it's not reflecting in a rough way. So let me switch to the perspective camera here for a short moment. And let me take a look at this panel down here. So if we take a look at that, and maybe let me reframe that a little bit. So we can, come on. It's pretty slow right now. So don't really know why. It's on GPU. Why wouldn't it? So there's this other concept. So if I select this shape, and you can already see that there is this attribute on its shape that is called M2A constant spec rough. If I go to the shading network here, and let me unlock that here for a moment, this M2A constant spec rough can be found here. So there's this little user data float node. So let's take a look at this. This is actually creating the roughness for that plane. So this is what's ultimately being added with that color jitter thingy. So before adding that color jitter, I can actually use this M2A constant spec rough as an input to control which surfaces are getting added some specular roughness. So on this panel, this is set to 0.049. So it's basically adding just a little bit of specular roughness to that thing. And let me lock that here. So if I go here and push that up and say that's 1, you will see that this is adding a value of 1 to that thing. Let us not add a value of 1, but rather a value of maybe 0.8 or something like that, or maybe 0.4. I still want to see. So if we take a look at the final resulting shader here, or maybe before we do, this is just an AI user data float node. So you can use that to read vertex color from objects, but you can also use that to just read attributes that you've added to objects from an object. So as long as that attribute is on the shape of an object and not the transform, Arnold will pick that up, and you can use a default color. So if I put that to 1, all of my plane would get completely rough. So that's on 0. But I'm telling it, that attribute you're searching for is spec rough. It's called M2A underscore constant underscore spec rough in Maya, because basically that tells the Maya to Arnold translator, this is an attribute that is meant for Arnold. This should be exported to Arnold. So this is this M2A constant part. And spec rough is just the name of it. So that's the name I'm using here, because Arnold will just search for the name spec rough. So if we take a look at the final panel shader and just unlock that thing here again, we can hopefully see, and it might be a bit hard to see on that panel actually, because it's reflecting the ground, whether it actually works or not. So let us see. If I change on the shape, here's this attribute. If I change on the shape that attribute, yes, we can see that. So let me just quickly take a look at the reflection. Let me turn off 3D manipulation here. The reflection of that wheel right here in that panel. If I add a constant of 1, the whole panel will be completely rough. If I go to 0.2, that panel will only be a little bit rough. So basically that's another way for me to pick individual panels and tell them be more rough if I wanted to. So for a close-up shot, you maybe go in there and say, well, I don't like the look of that. That has to be more rough. Or that's reflecting something particularly bad that I don't want to see that clearly. Make that more rough. So I can do that. So I can come in here just to show the concept. So let me just go in here. Let me say, and let us render a thing that we can compare with the other thing. So let me render a frame here, complete frame, and yeah, the IPR has to be on to do that. So let me take a little segment here, and that's been rendered, and let me store a snapshot again. So that's the snapshot, and then let me go in here, select that panel. So as I said, this attribute has to be on the shape. So when you go in here to the attribute editor and you select that thing and you go to attributes, add attributes, Maya will add that attribute to the transform right here. So you have to select your shape. You have to select it down here. So it's definitely selected. And you will go to add attributes. And you're going to add this thing that I just mentioned before. That's M2A constant spec rough. So that's going to be a value between 0 and 1, and I want its default to be 0. So I can add this. And it's done adding that. And if we are lucky, that actually also works right off the bat without actually reloading the scene. I'm pretty sure you had to reload, you had to update full scene before. So I'm actually very positively surprised by that, or I remember wrong. But anyway, that's absolutely cool. We can now use that value, and actually this little slider here, to basically control slowly how rough that panel should appear. So if maybe that was a part that's what changed, so maybe somebody went in there and said, well, I'm just going to take a spare part from an older plane and put it there because maybe some German shot some holes in that whole panel. You can do that. So this was fixed. An old hull panel of that P-51 was taken from another plane, put on here. It was rough because it was used. Done. So you can put, with that, you can just individually put some variation on your plane right there. So that's the one and last thing that you can do. And as I said before, I wanted to change a few things to give you, while experimenting, and myself some more control over the look of that plane. And let us do that right now as the very last thing in this tutorial, and then the series is complete. So the dirt shader on the engine. Let us just take a look at that again. So I'm gonna go here. We don't need those things anymore. I'm gonna not isolate my selection right now. Put the hypershade up here again so I can see a little bit more of that. So let us try to find that fuselage dirt material, and we're gonna go to isolate selection. So that's the dirt material. And as I said, we want to change a few parameters on here. So basically what I want to change is how light or dark the material is. So it's at 0.8 diffuse weight currently. I can do that by just pulling the diffuse weight down. So that's something I want to control. And there's also this roughness is on 0.006, it's on 0.061 right now. So I'm gonna copy that for later. So I can pull this up, and when pulling this up, this material will appear more rough. So this is what I kind of like want to be able to do with my dirt material. So let me put this back here on its default. So how are we gonna go about this? Well, we have to modify that shader a little bit. Let me pause the IPR here because we don't need that, and I'm gonna save that file because we are about to change our asset. So this material right here is the fuselage dirt material. It has this specular roughness input, and the base is this base weight. So basically the diffuse weight. So what do I want to do? I want to create a float constant node, which is a Maya node. So basically that's one of the only nodes in here. It's not a native Arnold node, but I like to use them. I like to use float math and float constants. They're pretty handy tools. So this is gonna be, how are we gonna probably call that on the rig? So we are going to call that dirt bright, in meaning dirt brightness from rig. So that's one of those things. So I'm gonna press tab at another float constant, and I'm gonna call that dirt rough from rig. So all I have to do now, for now, is just hook up this thing to the base weight and this thing to the specular roughness. So basically, since they're on 1 by default, this is gonna be a kind of like very rough, very bright surface. But I don't care because I'm gonna override the input of those two things anyway. So I have to go back to my little rig thingy here. So let us select the shader controller, and I'm gonna go to the very beginning to the shape, not the shape, but the transform here, and I'm gonna add 2 attributes, and I'm gonna call them basically the same as I called them in the shading network. So that's dirt bright. This is gonna be between 0 and 1, and this is gonna be on a 0.8 on default. So that is what I had before. Dirt bright, float value between 0 and 1, and its default is 0.8. So I'm gonna add that. Done. So I will add another attribute, and I will call this dirt. What did I call it actually? I called it dirt rough. So this is also gonna be between 0 and 1, and I'm gonna paste that value I copied earlier, so it's 0.061. So add. That's it. So I added 2 things to my shader controller, and if I go to the channel box, because it's easier to see, they are there. So the last thing that I have to do is basically just go in here, go to my shader control tab, and I need to tell my shader control to write to those 2 in float constants. So even though they are called constant, they do have an input value. So basically you can use that float constant node to just pass through a value, and we're gonna do that, and it's pretty simple. We're just gonna select the 2 things, and I'm gonna middle mouse button drag them over here to the node editor, and there they are. So basically I know that this shading network is gonna work, so really there's no reason for me anymore to have the hypershade open. So I locked the interface. So let me pull out the Arnold render view. We're gonna close the hypershade, and we have our 2 things here. And the first thing I'm gonna do is I'm gonna pin them so they never ever even get the idea to move around this editor, because they like to do. They kind of like have a life of their own. So I have my 2 attributes right here. So it's dirt rough and dirt bright. So Maya kind of added them in some random funny order. So I'm gonna connect dirt bright to dirt bright, and I'm gonna connect dirt rough to dirt rough from rig. Done. So let us start an IPR session. And let us turn off isolate selection, because we do not want to have isolate selection. We can close down the node editor. We did everything we wanted to do here, and we want to select our shader control, and let us see what we can do here. So to test things out, let me put that to a very low value, and yes, as we can see, that thing is gonna turn dark. So let me probably put that to 0.3, so it's not that dark, but pretty dark. So the dirt roughness is gonna change something, I guess. So I'm gonna put that to 1. And that is not gonna be that easy to see. So I'm gonna drag open a render region right here. And I'm gonna zoom in, and I'm gonna store a snapshot just to make sure that things are working as I want, and it didn't do that. So store snapshot, there it is. So let's pull that back to 0 again and render the whole thing and see if there actually is any kind of difference. And as you can see, there actually is. So this dirt material now has basically no specular at all, because a roughness value of so it didn't have any specular at 1. It now has no roughness, so it's pretty shiny, so you can see some highlights here. And if I put that to 1 again, it's pretty much a completely diffused material. And that's kind of like the thing that I can control now. So if I move back out here, please be faster, Maya, Arnold, all of you. So I'm gonna go here and let me just make this big, and let me lock that, because Maya tries to dock things that I don't want to dock to anything else. So this is the last step. Let me put that roughness up here a little bit, because it will make it easier to see some things. So the plane is rough. I'm going to pull the dirt brightness completely down, so in that way I'll also unfortunately eliminate my oil stain. So, but anyway, a brightness of 0 is probably never what I want to do. So 0.5 to 0.9 is probably the range that I want to use for this dirt. So let me pull that down to 0.4. So I don't want it to be completely rough. So let's put that at 0.5. So as you can see at these oil stains, that kind of works pretty nice. And I do have some more control over my material right now. So if I want to have a very dirty plane, and maybe not, as I said, not that, but maybe 0.1, and let's make that pretty rough, and then also push the dirt to its maximum. Now this is a dirty plane. No plane looks like that, but the setup works. So we can now put that down again to realistic values. So I'm just going to use my defaults here. So it was on 0.125. I like that 0.103. I'm going to put the panel seat to 0, and now let's turn it down to 0.01. And the dirt brightness, I'm going to put to 0.8. That's what it was before. And I'm going to pull the roughness down to 0.3. So that's probably a realistic range of values to not have the plane be as dirty as it could be. And I might now want to change, for whatever reason, back to my warm setup. So I'm going to switch lighting setups here. I'm going to move out with my camera a little bit, and let me just turn back on 3D manipulation so I can move about here, and let us pick some nice framing or perspective to render here. So I'm gonna go here, put it over there, and now we'll continue to let this render, and that's the end of this video series. So hopefully in all of those parts, so we're at about 7 to 8 hours recording time right now. So there's gonna be a lot of parts to this overview video. Hopefully, even though not all parts might be interesting to all of you, hopefully there was something in every part that you found interesting, or there were parts that you found interesting and enjoyed the series. It certainly was some fun making it. but also a lot of work. So thank you for watching. And as I said, I hope you found it interesting or learned something, or maybe just enjoyed looking at the work of somebody else, or yeah, basically just happy with having watched it. Hopefully that wasn't boring. There might have been some parts that took a long-winded explanation. I tried to keep it short, but yeah, really there's a lot to explain in a short amount of time, so I tried my best. So yeah, that's that. Probably gonna show the a part of the turnaround again at the end of the video, and maybe 3 shots I produced as a kind of test setup, and that concludes this series. So thanks again for watching. Have a nice day, and bye.